Hi class, so now we're just going to clean this up a little bit more. We want to make a few things a little more visual. And so if in your linear search you get this far, that's a really good step. I am going to show you how to make it look a little nicer. Hopefully you'll be able to implement that on your own for your linear search. Um, and let's get started. So right now when we're searching, our search count is not going up, and we're not showing the numbers that we've already looked at. So that's going to be the main stuff we're working on right now. So this function is working, but what I would like to do is every time we hit the button, I want to say used index dot push. So every time that we're finding another number, we're going to do used index dot push our current index. And that's going to keep happening until we get to the actual number. I think that might be all we need to do. Oh, and here, with that return, actually, I don't even think we need to do a return here. Let's take that out for a second. Because if they are the same, we're not in a while loop. We're actually good. So this actually does nothing. We could take the whole thing out if this works, but let's test this. Fresh, next binary search, next binary search. Okay, so that's great, but what I would like to do now is it's displaying the used index on top of our, let's check what's going on. So in our update list, nope, in our build list, what's happening? If am I in the list? Okay, so what I'd like to do is I'd like to put this first. So first we're going to check, are we the current index? So that will override if I'm already in the list. Because if I'm in the list and I'm the active, I'd rather see the active one. We can only see one. So next binary search, and we found it. Next binary search, and we get this nice visual. And then search count. I would like to update search count as we're searching. And now search count can actually, it's just the length of our used indexes. So I'm going to write another function. Update search count. And that's just connecting us to count. And let's see. Just copying code so I don't have to type as much. So we're going to do this. I'm going to say the inner HTML equals, and what language are we using to start? Search count colon. So I'm going to say search count colon space plus the length of our used index. And every time we draw the list, I'd like to automatically update this search count. So now every time we call display list, it's also going to update the search count. So I don't think we need to do it anywhere else. So let's reset button. So see our search count's going up. Now it keeps going up. I'd like to stop that. So when it's found, I want it, oh, that's because it never found the number. So that's pretty fun. So new seek. If it doesn't find the number, so I do want it to stop incrementing though. So in binary search, let's see. If they are equal, I think we might be missing one piece. Okay, if upper bound is less than lower bound, exit. It doesn't exist. So at the top here, I'm going to say if upper bound is less than lower bound, return. Lined up. And that should fix the seek forever. So binary search, boom, new seek. Binary search, boom, new seek. Binary search, binary search. There's only two. That's cool. Binary search. And if you see, none of these get too long because these binary searches are so fast. I guess let's go for it. I'd like to invalidate things now. Do I really want to? Yeah. So here we have this obsolete index. And you do not need to do this in your code because there will be no obsolete. Set obsolete index, and we are going to say lower bound, comma, false, and set obsolete index, and this one would be upper bound, comma, true. So what these arguments are is the number that we're setting as obsolete, and if it's false, we're going to set, we're going to go to all the numbers lower than the number that we pass in. If it's true, it will be all the numbers higher than the number that we pass in. So function set obsolete index. And yeah, these are just indexes. So index and then upper. And what we're going to do is we're going to say if upper is equal to true, then we want to set all the numbers above index into our obsolete index. For I equal var I equals index, I is less than list.length I plus plus, and then we're going to say obsolete index dot push I. I'm going to say if upper equals false, or we could use an else statement here. Doesn't really matter. We're going to say I is equal to index, and then while I is greater than or equal to 0, and then we're going to subtract 1 from I each time, and we're just going to do the same exact push. And I think that's really it. So let's see how that works. It also might look worse. So it's, if you see, we're obsoleting a little too low. So it's I'm going to do lower bound. Well, actually, we're just going to do current index. Work. Cool. I think that actually looks kind of nice. New seek. New seek. New seek. Hey, I'm kind of happy with that. Oh wait, what's the problem here? Oh, so 73 is not in the. So it allows me to push through if it doesn't find the number. That was the largest number. That's a bug that I'm not going to concern myself with right now. It's more of a that's fun. Okay. Thank you. I hope you enjoyed this, and I hope this is helpful. And good luck with your linear search.